Good afternoon, all. My name is Shivasprasad. Now I am going to present our work on design and simulation of hydrogen fueled free piston engine generator for cold ironing application. Our project industry partners are H2CHP and Johnson Matthey Limited. The maritime sector contributes a 2 to 3% of carbon dioxide emission, and the ships which are which are in ports are rely on their onboard diesel generator to power their auxiliary equipments, which emits harmful emissions such as sulfur oxide, carbon oxide, uh, carbon dioxide, particulate matter, and black carbon. These harmful emissions impacts the climate change, ocean acidification, and health issues. Our project aims to reduce these emissions through a novel technique called cold ironing. So, cold ironing is a ship-shore solution which allows the ships to turn off their onboard diesel generators, which avoids the or which uh, reduces the emissions from the diesel generator. The current ship-shore solution is highly cost-effective and it requires high grid upgrade, which making it challenging in port areas for maritime industries. So our approach is to integrate the cold ironing application with the hydrogen fueled free piston engine generator, offering fuel flexibility, dynamic load response, and cost effective solution. This can be scalable and provides um, reduced emissions with their operating requirement. So the aim of the project is to design and simulate the free piston engine generator operated with the hydrogen fuel. The key project objectives are to design and developing of a free piston engine generator, to evaluate its performance and the emission reduction potential, and also we are going to demonstrating the technical feasibility and economic viability, and also to develop a digital interface for dynamic operation condition. So here is we have developed the free piston engine generator. The test rig, as you can see on the slide, it consists of a compact piston assembly consisting of two engine cylinders, heat transfer equipment, and power generating unit. It also consists of data acquisition system and control system, which monitor the in-cylinder pressure development and piston position throughout their complete cycle. This ensures the this ensures the good operations as well as real-time data evaluation. We also developed the free piston engine model. It is MATLAB Simulink model based. So it comprises of thermoelectrical dynamic model, combustion model, and generator model, uh, which to analyze the combustion parameters and power generation as well. The main contribution of this free piston engine model is to help in optimize the engine efficiency and the performance parameter under variable conditions. This is the initial results of FPG model. As you can see on the slide, as you can see on the plot, the free piston engine model gives about 40 percentage of efficiency, which offers the good conversion, good energy conversion for cold ironing application. The power output, the electrical power output, is about 24 kilowatt, which ensures the reliable power generation for cold ironing application. And we also calculate the levelized cost of energy of hydrogen, and we compared it with the different fuels such as methanol and ammonia. As you can see, the hydrogen has slightly higher low cost of energy, even though it is most reliable due to its clean combustion property. And we also calculate the number of free piston engine generator requires for the different different demand of the ships, and as you can see, if the vessels of more than 200 meter, then it may require about 100 free piston engine with the hydrogen flow rate of 0.25 kg per second. In summary, our free piston engine offers compact and efficient and clean energy solution for the cold ironing application. This free piston engine can be scalable and provides solution for the cold ironing application. Coming to the next phase of the project, we are going to conduct the experimental on free piston engine using different variables, and also we are going to assess its impact on port environments, and also we are gonna study the feasibility of the free piston engine generator, and finally we will going to develop or create a digital interface for dynamic performance analysis. So this is my presentation. Thank you for listening.
Good. I guess we open the floor out for anybody who's got any questions. Yeah, please go ahead.
Yeah, the first one is, I mean, is this meant as a direct replacement for shore electrical power effectively in ports where shore electrical power infrastructure is not available? Is that correct?
Yes.
Okay, so, because obviously with the Fueling Maritime, there's a huge investment program coming in place for shore power, so, but I suppose there will still be some ports which don't have the infrastructure available. Is that your target?
Yeah.
And what about redundancy effectively? Obviously, I mean, I suppose you've always got the backup of going back onto the ship's generators, but you don't really have any redundancy with this engine. If this engine fails effectively, then what is the redundancy plan? Do you have a standby unit, or are you just planning on the ship going back onto the one electrical power?
No, ship will have their onboard
Yeah,
diesel generators. Yeah.
Yeah, so that's the backup, obviously.
Yeah.
But you don't plan on having another backup?
No,
It's
not
just
for this.
the one engine. Okay, thank you.
Yeah.
Would you mind just sort of saying your own background?
Yeah, sorry. So I'm a marine engineer.
Right.
I work for North Standard, which is a shipping. We effectively insure shipping liabilities. So that's what we're interested in. But we're trying to take a big interest in help our members and customers with their decarbonisation journey. This is of interest. Was this with Professor Roskilly?
Yes, he is leading.
We spoke to Professor Roskilly, of course. That's interesting. I'll catch up with you after this.
Hawaii is here and some small one. So
We're going to chat after what?
Yeah, great.
Because it works with ammonia as well. And some
Yeah, I'll be with
future fuels.
Thank you.
Thanks very much. Yeah. John, I think, did you have your hand?
Yeah, just a very quick question really for you.
Yeah.
So I know we talked there about like ship to shore, shore to ship power. As part of your project, does it consider actually putting the reciprocating engines on the vessels themselves to generate power? So there's no need for that shore link?
No, we can use it as a onboard power, source for the to the ships. And also we can have a, instead of grid, we can have a high power or high capacity free piston engine altogether to supply the electric power to the ship.
Yeah. No, that's great. And the only reason I mention it really is one of the barriers amongst all of the things that you talked about in terms of power and the infrastructure costs, etc., is also the flexibility. So, because different vessels obviously have different positions for the connection points. So, if your free piston engine could be incorporated on the vessels themselves, it potentially gets rid of that flexibility.
Because of it, FPG has compact in size, right? So we can use for onboard as instead of diesel generator. Yeah.
Great. Thank
So
you.
it wasn't in scope for this project, but we've looked at it in drones, on board cars, trucks, and vessels.
Oh, right.
Yeah.
Oh, fantastic. Thank you.
Great.
Thank you.
Thanks very much. Yeah, it's probably just worth noting that John's obviously Port of Middlesbrough.
Oh, sorry. Yes, I should have said that as well. Yes.
He's obviously got some very knowledge of the application of cold iron as well. We've got a few minutes. Did you want to add anything else on the application of? From Teesside, we're also involved working with Durham on this one. Yeah, the application is cold iron in its first instance. But there's certainly scope has been a portable mobile power unit effectively as well, and I guess through discussions, Andy, that's something you've learnt about, that the potential of this is across different sectors there as well, doesn't it?
The history is about 15 years long. So it was started in the lab in one kilowatt size, and now it's grown. There's a 30 kilowatt unit on test there. We've just spun out. It's raised quite a bit of money to develop a prototype with Ricardo, who are a large manufacturer of developing engine technologies, and that's now scoping to do a 100 kilowatt system, which is then scalable for exactly this occupation, and that's the target market for that spin out to focus on. So that's being built right now, and I get text messages about deliveries and stuff. So it's quite exciting.
I think that's the exciting part of it. You've actually got something tangible
Yeah.
to break and make and work.
Yeah, and there's
Which is
real
quite
people,
exciting.
not just researchers working on it here. Lots of experience.
So what's the 100 kilowatt machine going to be used for?
The code iron is
Yeah.
is
But I mean, it's quite a small load, that isn't it?
yeah. So the idea would be multiple 100 kilowatt systems.
And just, sorry, as a final question, just on that one then, in terms of the size, so if, for argument's sake, you needed 1,000 kilowatts of power, and you had, so that'd be 10 of the 100 kilowatt
Yeah.
units, how much space, would they fit in a container
Yeah,
together,
so-
or would you need sort of seven, just to...
So the design is about half a megawatt would go in one container. So for what you need two.
Okay,
But that's all under development at the moment. But that's broadly.
that's the sort of, yeah, cool, fantastic, thank you.
Thanks very much. Some really good questions as well.